So giving a little bit of time for everyone to catch up with setup and things like that. It's been said before, I will say it again. Everything we're doing today in the workshop, we've got people on hand for questions and to help, but everything we're doing is basically covered in the setup guide, the workshop instructions at bridgecrew.awsworkshop.io, which we've already linked. So within there, we're currently at 3215. Nothing would stop you doing this on your own AWS account, obviously, but we have just reading the comments. We have these Event Engine accounts. So, someone mentioned cost, obviously they're being covered by AWS. So makes sense to use them. And yeah, we're at 3215 and I'll basically be walking you through everything from this point. So welcome everyone. And, while we will jump into the setup, we're just going to cover a little bit of context to start with. So what are we doing here today? What's the point of all of this? Well, obviously, most of you will have heard of DevOps, the idea of having your operation and development teams kind of embedded together so that, instead of throwing code over the fence to an operations team and then the operations team throwing logs back at developers, everything got better when those teams started automating the application lifecycle as a single journey, from the very moment the infrastructure is created to deploying code, to looking at that code, to updating versions and carrying on that life cycle. We're now in a scenario where that kind of DevOps style practice has led us move from, manual deployments that required, humans going and talking to other humans to get something done, to the point where through Git, you can commit a change. That change can go through CI/CD, that change can go through automation. And, we can potentially go from having, 1 or 2 deployments a month to potentially thousands of deployments to production a day using that automation. And so the team that kind of historically wasn't involved in that was security. And that with the automation being available to kind of do those deployments, we are obviously going to not benefit from the fullness of that automation if we have any manual steps kind of in that process. So, a traditional security approach of having kind of a blessed VM image or a blessed container image, or the idea of validating an environment that's been built for security by testing against the environment before moving it into prod, those kind of traditional ways of looking at securing deployments aren't really going to scale with DevOps. So what this today is all about is kind of looking at, squeezing that sec and squeezing kind of DevSecOps into DevOps and going, well, when we have infrastructure as code, when we are using APIs to deploy our infrastructure, such as AWS, infrastructure as code, like CloudFormation, Terraform, Kubernetes manifests, we're already in a position where we can automate the security scanning as part of the pipeline. We can test the security of our infrastructure as code just in the same way we test the security of our Python or our Golang with tests in our pipeline before we deploy it to production. So that is a brief primer on kind of DevSecOps. And that's exactly what we're doing today. We're going to start with scanning some infrastructure as code manifests. We're going to look at how easy that is to do, as a developer locally on your machine. And then we're also going to go, okay, well, let's take that, let's embed that into our CI/CD pipeline. We're going to build some CI/CD pipelines in AWS, and we're going to look at what that looks like to actually give us that kind of full lifecycle security information for our deployments. So without further ado, let's jump into it. Obviously, lots of flavors of infrastructure as code. As I've just mentioned, we have Terraform, we have CloudFormation, we have Kubernetes manifests. Some of them get templated out into other languages such as Helm. And so today we're going to be focusing on CloudFormation, but don't let that put you off if you are a Terraform user or you are a Kubernetes or Helm or any other style of infrastructure as code templates. All of this knowledge and kind of all the processes we're going through in this workshop just converts beautifully. Like the tools we're using, Scan, CloudFormation, and Terraform, apart from the language spoken, like all the instructions are pretty transferable. So CloudFormation is basically an infrastructure as code language for declaring Amazon AWS resources. So if you've never seen CloudFormation before, don't worry about it. Like all the examples are kind of in repos that we're going to clone, and there's no kind of writing CloudFormation from scratch in this workshop to get a handle on the security side of things. So this is what a sample piece of CloudFormation looks like that's going to create Amazon S3 bucket. You can see we're setting properties of the S3 bucket like you'd expect in infrastructure as code. We're setting a deletion policy and all that kind of good stuff. And then we're also pulling data out as outputs at the end of the piece of CloudFormation so that whoever runs this CloudFormation kind of can see the URL to the bucket and things like that. So in a nutshell, that's a piece of CloudFormation and not necessary, so don't follow along with this for the workshop, but you'd then take something manually, for example, using the AWS CLI, and you'd be able to basically run that CloudFormation with the AWS CLI, and it would go and infrastructure as code you that S3 bucket. So without further ado, let's see what we can do about scanning infrastructure as code in this in the same way for security as we do with our regular code, our application code. So if we skip down through section 3 of the prerequisites for those that have it open in a tab, I'll try and reference back to the pages as much as possible, but just know it's there if necessary or if you want to refer to things afterwards. We are also going to need a Bridgecrew account. Now, like everything else in this workshop, it is free. So if you go to bridgecrew.cloud, and you can find that on 3.2. You can find a link to bridgecrew.cloud here. I'm already logged in. You will get a welcome page, and there are multiple ways there to sign up. So we support GitHub, GitLab, Google Auth, or you can click work email, sign up down at the bottom, work email, and you can just specify your email address, and that will email you a one-time password. And so we will need that account. And one of the first things we will do after that is look at the simplest view of infrastructure as code. So I'm having a couple of caching issues, it seems, with my web page. So I'm going to quickly explain something here. Bridgecrew has an open source tool called Checkov, which we use for infrastructure as code scanning. We've aliased Checkov to Bridgecrew. So whether you pip install Bridgecrew or pip install Checkov, they're basically the same tool. So this page should say all Checkov, but seems to be refreshing some, but not others. But I'll just leave that as a caveat. And yeah, any issues, obviously ask in the chat, and one of our lovely panelists will help. So what we're going to do is, first of all, sign up for Bridgecrew, and then also make sure that in our new CLI, courtesy of Rob and Yaniv, within our Cloud9 environment, which we're going to do basically anything that requires typing, commands, all that kind of stuff that emulates like your local environment, we're going to do in Cloud9, as I said, for simplicity. So let's go and find our environment. Move the Zoom sharing panel out of the way. I'm just going to move this over here for ease of access. And then, as you can see, I'm followed along with the instructions as Rob as well. I installed JQ and all those dependencies ready for us. And so what we're going to need to do now is we're going to need to, and I'm already in the env based on the pip env that was created by Rob as well. And what we're going to need to do is pip install, and this is where it deviates slightly. You might have slightly different instructions. We're going to pip install Checkov. So sudo pip install Checkov, like so. And that's going to go and download and install the Chekhov CLI. So the Chekhov CLI is usable to do security scans of infrastructure as code locally on your machine, but is also designed to be embedded in CI/CD pipelines, as we'll see later on in the workshop. Please do, Yaniv, Rob, Peyton, interrupt me if we have any questions or anything that needs clearing up. Appreciate it. Okay, so once we have Chekhov installed, the other thing we're going to need for later is the API token from the Bridgecrew dashboard. We're not going to use that yet, but it might just be worth writing it down. A great place to write it down might actually just be open a notepad in Cloud9, since we have everything in one nice place. And what we can do is we can go to our Bridgecrew account once you've been emailed that temporary password, and you can either click the link in the instructions, which will take you right there, or you can go in the Bridgecrew dashboard that you'll log into to integrations and API token and copy that from there. And then we will just save that for a later date. Okay. So at this point, we are doing pretty well and are ready to kind of go out of the dependencies and look at some infrastructure as code scanning. So as I said, the first thing we're going to do is look at the simplest way in which we can do security scans of infrastructure as code. And so I'm going to introduce at this point, and we're on section 4.1 for those following along on the web page. I'm going to introduce at this point a sample repo that we've created here at Bridgecrew called CFNGoat. And CFNGoat is purposely vulnerable CloudFormation. And Bridgecrew maintains a few of these Goat projects, CFNGoat at github.com, bridgecrew.io/CFNGoat, and also TerraGoat for Terraform fans. As I said, a lot of this is very interchangeable with different infrastructure as code. So within CFNGoat, what you will find here, and please do not try and run this CloudFormation against an AWS account you care about. It's meant to be used to show, detecting security issues in CloudFormation before deployment. And so basically what we've done is written the most insecure, purposely vulnerable CloudFormation possible. And so for those of you familiar with CloudFormation, you will see that in CFNGoat.yaml, we have a massive amount of CloudFormation written, but that purposely, disables secure defaults, leaves S3 buckets wide open, everything you can possibly think about as a really bad example of secure infrastructure as code. And so what we're going to use CFNGoat for is our sample code base. And so what I'd like everyone to do is clone this into their Cloud9 environment. So what we have in the instructions is the nice copy and pasta to do that. So we can simply go to our CLI down here. And we can clone CFNGoat, change directory into the newly cloned repo. And then if we look here, we'll see we're on branch master. And also because we're in a fully fledged IDE, we can open that here and see that we now have a copy of that in our Cloud9 environment. Cool. And so putting it all together, what we can now do, and this is why you need the API key from earlier, the simplest way to test your infrastructure as code security is to run the Chekhov command that we just downloaded into our local environment. So here you can see I will have Chekhov. If I type Chekhov-help, we'll get Chekhov's output. And we can run Chekhov to scan that local infrastructure as code. So if I I don't know why I'm not clicking the lovely little copy links that we're providing here in the workshop. So what I have here is I can run Chekhov, and you'll see that what we're asking for here is the API key that we copied down earlier. So you can either save that to an environment variable, or you can just replace that placeholder directly with the API key here. So the reason we're specifying this API key is Chekhov is going to scan this CFN-goat YAML file for any security issues. It's going to output the issues it finds on the CLI, but it's also going to send a copy of what it finds, that kind of output report, to the Bridgecrew platform, so that if we were running this in CI/CD, or if we were running this across multiple developers, we can kind of keep a log and information of all the vulnerabilities across all of these different code bases. So what will happen is Chekhov will go away, scan that YAML file, and will come back providing us with a number of recommendations and issues it's found with our CloudFormation. So obviously, we're going to get a lot of issues from this because this is purposely vulnerable CloudFormation that we've written in CFN-goat. So, and for those of you catching up still, we are on 4.2 on the Chekhov CLI. So while that is scanning, see how we're doing. Oh, there we go. You will see that this is the kind of default output for Chekhov. And what it basically shows for each issue we found is we have a check ID. So this is the ID that's failing, and Chekhov has a load of built-in checks. And we get a description of the issue. We get the individual resource. So within CloudFormation or Terraform or any language, you'll have multiple resources in a single file usually. So for example, in this case, we have an S3 bucket called logs bucket, and that is the resource that this check is failing on. This check might also fail on another resource in the same file. So we might get two outputs, but with two different resources. And then we provide where in the file, so check cfngoat.yaml, line 643 to 662, we provide the actual CloudFormation object, the thing that has failed. So, and then for each as well, we also provide a guidance link. Now, think of this guidance link as like kind of a virtual, mini security team helping developers that are running Chekhov. The idea of this is it's going to provide context as to what this is. Like, what is this error? Why do I care about it? Why is it making my infrastructure as code less secure? And so we'll provide context for basically every error we flag up, just to try and provide more information to the development teams receiving these messages. So in a nutshell, Chekhov is basically allowing you to run this against any piece of infrastructure as code before you've deployed it, even while it's just still in your local development environment. And that's going to just help you check before you commit whether you have any kind of security issues. Hey, Rob, did you have a question?
Yes. Hey, Matt. Yeah, I just wanted to know, CFN-goat seems to be geared towards CloudFormation. Does it support Terraform templates as well?
No. So for that, great question. As I kind of briefly touched on, we have a few different kind of goat projects. So similar to CFN-goat, we also have TerraGoat. And what you'll find here is exactly the same. It's purposely vulnerable. Due to the way Terraform is written, we've broken this down into kind of more Terraform files rather than the one big CloudFormation file. But you'll see very similar in here, just like CFN-goat, we have lots of different purposely vulnerable resources. And if we really wanted to, just for the giggles, we could go into our, and don't follow along with this if you don't want to on the webinar, but just out of interest, we could technically, here we go, come out of CFN-goat as a Git repo. We could git clone TerraGoat. We could change directory into TerraGoat, into Terraform AWS, for example, where we saw all those files. And if we ran Checkov-D, which is basically recursively scan this directory for any infrastructure as code you find, we'll find that the results we get back this time from Checkov won't be related to CloudFormation, they'll be related to Terraform. And again, we see the resources, we see the pieces of Terraform, we see the checks that are failing based on that resource. And because we scan multiple IAC types, we also clearly found a Docker file somewhere in that repo as well. And so we've done some Docker file scanning as well. Yeah, great question. Thanks.
Excellent. Thank you.
Cool. So what you will notice there is I ran Checkov-D dot rather than adding the API key. And that is because there's a few different ways of using Checkov, again, all covered in 4.2. If you want to kind of go back and look at this later, you can run it locally without the API key to just get the local CLI output. But providing the API key gives us some really cool features. So those of you that noticed at the end of scanning against CFNGoat with the API key, you were given a URL at the end of all of this output, at the end of all of the information that's given on the CLI, you're given a URL as well. And that URL basically means that in the Bridgecrew dashboard, under code reviews, which is where the URL is taking you to, every time you run Checkov with the API key, you get a log of that run against, what repository it was, what branch it was on, how long ago it was and how many errors there were as like a record inside this code review screen. And so what this code review screen, you can see that was 5 minutes ago when we ran this. And what this code review screen is going to do, it not only gives you a searchable, more easy to kind of digest, easy to view viewpoint of, the massive CLI output, but it also tries to provide suggestions. So for things that are, a known fix, for example, how do you turn encryption on this particular resource for this S3 bucket? This is actually going to provide you and your developers, hey, like, this is how you fix this problem. So you don't need to go and research, you don't need to go and dig through, security documentation for S3. Like for the piece of CloudFormation or Terraform you've written, this is how you solve that problem. So this is, our code reviews page, and this is one of the benefits you get of kind of tying. I'm just going to close that down. This is one of the benefits you get of tying the Checkov CLI into the Bridgecrew environment. And what happened here was we didn't get any output because obviously I'm in Terraform rather than CloudFormation because I changed repos for that little demo. So let's go back to CFNGoat and run that again. And we'll see when I run that again, you'll see the URL I was talking about. And you'll see that links us to these code review pages. Also worth noting, they don't just show up as an individual run in the code review like this. Any outstanding incidents from the latest run for a given repo also go into our incidents page within the platform, where you can do quite a lot of powerful searching and again, just more filtering. Now, incidents by default is going to show errors coming in from all infrastructure as code sources. That might be Checkov, that might be your CI/CD pipeline, that might be runtime resources in AWS, which we're going to cover a little later on. But what it does allow you to do is then filter quite nicely on those. So we have Bridgecrew CFNGoat, which we've been scanning here, and this name will be related to what you are what you're running on your Checkov command. So you see here, repo Bridgecrew CFNGoat, that ties into our environment here. So we might only want to look at critical and high severity issues that we got out of that Checkov. You'll notice that the Checkov output doesn't have any severity on the CLI. So within the platform, we can do a lot more powerful searches or against benchmarks or against certain categories of issue. So if we go back here, you see we've nothing high or critical. Let me just check my filters are all okay. Bridgecrew CFNGoat. Open issues. What have I done wrong there? Call it Bridgecrew CFN Go instead. I might have typoed on my output. But yeah, so just an example of another way of seeing this is we can then see here for these resources, Bridgecrew IO CFN Go. This is a high severity issue donated by the DOT. And if we can see based on our filter, how many items are affected by this particular policy. And, that might be a lot. So for example, here we had a lot of S3 buckets in our CFN Go environment. So we're getting a lot of errors for this particular policy. Block public policy needs to be enabled. It wasn't. And then for each of these, we can click into them and kind of explore a little more, just in a much nicer environment than kind of drilling through the CLI output in Chekhov. So at its very basics, I hope you can appreciate how that one command tied to the API key for the Bridgecrew account is going to allow you to really easily kind of collect information and then see your current state. Where are we? What issues do we have in our current infrastructure as code repos? And then, as I said earlier, we support a lot of policies out of the box, which is what you're seeing the information from. If you want to see what all those policies are in the version of Chekhov you have, because the policies are embedded into a version of Chekhov, we're adding new policies all the time, both ourselves and the community, and --list will basically give you all of the current supported policies, what they affect, for example, Kubernetes, AWS, Terraform, and also some descriptions about them. And what I've done there is basically kind of done a bit of a whistle step tour covering 4.2 and 4.3, looking at Chekhov, looking at Chekhov scanning, and then also covering kind of seeing and sorting and filtering that information in the dashboard. Hey, Yaniv.
Hey, sorry, Matt, don't want to stop you there.
No worries at all.
We're getting a question, and I just want maybe if you can address it as you were talking about policies. And the question is like, can we add also our own policies or custom policies, I guess?
Yeah, for sure. So within the two-part answer to this. Chekhov, obviously open source. Policies inside Chekhov are mainly written in Python or graph-based policies for Terraform. So if you wanted to contribute your own check for Chekhov and you're familiar with Python, you can definitely go and look at that. The easier way to do it within the platform is, yeah, we do support custom policies. So in the policies page here in the platform, you'll see all the built-in policies that are provided by Bridgecrew. And you can see, just globally across everything you've got integrated in your account, how many have passed and how many have failed on that individual policy. And you can actually then use that as a filter directly into the incidents page by clicking inspect. And what you'll get is the filters already created to just show you that particular policy and what you want to see there. But on the customization side, if we hit new policy here, we have two options. We can either use a visual editor to basically define, hey, like I care about this policy being AWS. I want to check against these resource types, for example, Terraform and CloudFormation resource types. And we're dynamically pulling those from like supported Terraform and CloudFormation resource types. And then once you select, say, EKS cluster, you can then go on to define, which of these attributes that would be within an EKS cluster object based on the API for that object typed on AWS. So I want to make sure that, the certificate authority equals something. So you could build it that way. Alternatively, we have a code editor. And so for this, as you can see, it's quite a simple YAML format. Provide some metadata, name, guideline, category, severity, and then we have a simple language for like conditions and a bit of a type to complete editor here. So what I actually have is a example policy here. So as you can see, this very closely matches metadata and then the definitions. And what this is actually going to do, this is a runtime policy. So this is looking for things fed into Bridgecrew, not from CFN Goat and not from TerraGoat, but from an actual live AWS account. And so this policy is basically going to tell me an alert on any AWS EC2 instances that don't belong to a VPC. And the way it does that is it goes and finds all the AWS instances, and then using like a graph database, like working out the connections from one object to another, it goes for that AWS instance, find any network, elastic network interfaces, ENIs, attached to that instance. And if those ENIs are connected to a AWS subnet, tell me if that subnet doesn't have a VPC ID, i.e. we're connected to a subnet that isn't a VPC. So if we take this and put it in our policy editor and hit test, what we're going to see it do is live test that policy against all the resources that are currently tied into your Bridgecrew account. So that might be the CFN Goat content that's come in through Chekhov. That might be AWS accounts that will show how you connect later. That might be automatic scanning of GitHub repos that will also cover. And as you can see here, it's actually found one active thing in my environment, which is matching this policy. So you don't have to kind of create a policy and then see whether you're getting violations. You can make sure the policy is finding the resources you care about while you're editing the policy.
Thank you. Wow. I mean, I'm more of a GUI person. I would probably start using the dropdown first, but I mean, this is amazing. Like, if I'm thinking about DevSecOps and the whole what we try to preach all the time about trying to get your security teams as much as at the start of the process as possible, and make sure that they can't be everywhere, and it's not just an audit that comes in after you go into production and everybody has to stop everything just to inspect what we have. This is perfect. Like if I can write my own custom policies about any resources that I plan to provision in my infrastructure, it's just awesome. So thanks.
Cool. Yeah, no worries. Thanks for the question. So as I said, we've kind of covered CLI, and we've kind of introduced quite extensively the Bridgecrew dashboard and policies and some of the features. All this is well and good, but you're not realistically going to expect your developers to run Chekhov manually every time they make a change. We've already got far too many commands to run as devs in an automated pipeline. We've got to do git add, we've got to do git commit, git push. It's far too many commands. So expecting more manual commands to run is not really the DevOps or the DevSecOps way. What we're obviously going to do is automate that. So in module 5, we're going to look at how we create a CI/CD pipeline. And obviously, you probably won't be creating a CI/CD pipeline from scratch. You will already have a pipeline that's building your code base or creating your Docker images or doing regular testing against your application code. But we're going to build one from scratch here just to demonstrate kind of a simple CI/CD pipeline that can automate this Chekhov workflow for us. So the way we're going to do that is we're all going to get our own copy of CFN Goat by creating a fork on GitHub. And through that, we can then kind of trigger changes in that CloudFormation ourselves, because obviously no one will have write access to the Bridgecrew IO CFN Goat repo. So what I need everyone to do is follow this link on section 5.1 to CFN Goat, which we looked at earlier. And if you could just hit fork, I've already got it forked into my personal GitHub repo called Metahertz, but you will be given the option to fork that into your personal repo. So if you go ahead and do that, it'll take a few seconds. And what you will end up is something like this. You will have your GitHub username, CFN Goat forked from Bridgecrew IO. And then this is a version that you can change, edit, modify, etc., etc. And again, if you want to follow through this at a later date, all the instructions we're going through are here in 5.1. Hey, Rob.
Hey, Matt. We have a question. Sergio Cruz asks if he can link multiple AWS accounts and scan them with the same custom policy.
100%. So I'm going to deviate slightly just because it's, a great question. We actually cover this in section 6 under AWS Runtime Scanning 6.4. But just in a nutshell, within the Bridgecrew platform, basically adding things is all about the integrations page. So in integrations on AWS read-only, I actually got one environment added. We're going to add this new environment that we've just provisioned from Event Engine later on in the workshop. But basically, yeah, you can add as many accounts as you want here. And in terms of incidents, they'd all just turn up as their own account ID in the filter. So right now that's one, and you can alias these within the platform if you want to. But yeah, so you'd end up with 1, 2, 3, 4, however many cloud accounts you wanted to add, and then they'd all get scanned by whatever, all the existing policies and whatever custom policies you wrote.
Excellent. Thank you.
Cheers for the question. Thanks. So quickly heading back to Module 5, Automate. Hopefully that will have forked now. And what we're then going to do is we're going to tie that fork into a AWS code build, an AWS code pipeline CI/CD system, so that the idea being when anyone makes changes to your fork of CFN Goat, it's going to get scanned with Chekhov, and those details uploaded to Bridgecrew before allowing that build to succeed or continue. Because further down that pipeline in a production environment, you'd obviously have CD where you're looking at actually pushing those changes into production. So the idea is to stop that, just like any other test against your application code failing. So as of 5.2, we are in the instructions to create a integration to tie Bridgecrew into AWS code build. And then we're going to be creating a code build project in AWS. So as far as the Bridgecrew integration is concerned, again, integrations tab, and then we find AWS code build and we click add subscription. And we're just going to leave that up now in this tab. So we're going to need to copy and paste these parameters. The first one we're going to copy is this. Now, this is a local AWS CLI command to put a API key into our AWS account so that the code pipeline can securely access it when needed. Now, usually we'd have to go and set up like our AWS CLI and our AWS config file. Another benefit of the Cloud9 environment is because it's already inside the AWS account, it already comes with the authentication tokens and the AWS CLI is pre-configured. So I can, and I urge everyone to do the same, I can basically just paste that command in there and run that, and that will go exactly where we need it to go into our AWS account. So we're putting this key in as a secure string into the AWS forgotten the particular name of that, and anyway, into the parameter store, and we can see that it was successful, and we got a response back. So for that part, that's all we need to do. I'm sure Rob or Yaniv will correct me on the full name of SSM. And then the next thing we need to do is just keep that open, because we're going to use this CI pipeline configuration as we build our code build pipeline. So for the code build pipeline, what we're going to want to do is have a separate AWS page open. So I'm just going to click. I'm going to go back to the. Oh, that's not worked. Okay, what I'm going to try and do is. I basically I don't want to have to close Cloud9 down as an IDE, but I do want to go and create some other stuff. So Just going to reload a couple of pages that were logged in and find one that is working. Yeah, there we go. So what we want to do is we want to head over to code build inside AWS. And we want to create a build project. And then all of the things we need to do inside this project, just moving my tabs around for ease of access. Everything we want to do within this project is kind of documented in the workshop. So we've tried to highlight in kind of terminal font in yellow, kind of any input that's needed. So create build project. We are all just for simplistic debugging for our wonderful panelists. We're going to hopefully call this the same name. Obviously, if you need to change some things or it's your own environment or you're watching this back on a video, they're just names, but do beware if you change them that if we're doing something later down the line that requires this name, that it was changed from the default. So we're going to call this Bridgecrew tutorial. And then for source, obviously it supports having the source code in multiple places, but our CFN goat fork is in GitHub. So we're going to choose GitHub. And then we're going to connect to our GitHub account using OAuth. So we click the button, it redirects us to GitHub login. There we go. And then we authorize. And what that's going to do is that's going to allow the code build environment in here to access our GitHub account so that we can read and write and access our CFN goat fork. So at that point, you should be able to either provide a public repo, or what we're going to do is say repository in my GitHub account. And then this is going to allow us to just search for CFN goat. And you can see we'll all have whatever our GitHub username is and the CFN goat repo we forked. And that's all we need to do. We need to say this code build pipeline is related to this source code stored in this repo in GitHub. And then what we're going to do next is just change some of the image settings. So again, we've kind of gone into all this detail if you want to follow along afterwards in the workshop environment. We've tied our Git repo, and then we're going to select managed image. And we're just going to say, what is our CI/CD pipeline running on? When you kick off a CI/CD pipeline, it's obviously going to be running some code on some environment. So in our case, we want that environment to be Ubuntu, and we're going to select standard runtime 4. No reason not to, just that we've tested all this against standard runtime 4. So we're keeping it in the instructions for consistency. And then new service role is absolutely fine. And then once we get down to build spec is basically code build asking what the instructions are. What is the pipeline you want to run? Peter, I'd say sit back and watch potentially. If you wanted to jump in, fine. But yeah, you'll have the environment available to you for a while after this. So, by all means, just enjoy and then go back through it. So the build spec is basically what is the pipeline we want to run? What commands are we running? Are we running checkoff? Are we running a linter? Are we running, a test suite for Go or Python? And there's two ways to provide this. You can either provide a build spec file within your Git repo, which obviously we don't have currently within CFN goat, or you can directly give it the build spec file in the pipeline. So for the sake of the demo, that's what we're going to do. So if we click insert build commands and we switch to the editor and we clear out everything that's there, this is actually what's provided to us in the integration page that I said leave open for the Bridgecrew integration. So if we single click that, single copy that and paste that, it's that simple. We're basically saying, yep, this is a pipeline that's pre-configured to run checkoff, to pull the key from the right location, to send the results where they need to go. And so you can just paste that into, make sure you clear the demo defaults out from the box first, paste in the Bridgecrew item there. And that is pretty much it. We can then create code build project. Now, at this point, we have a code build environment. And if we click Start Build, it will fail. And the reason it will fail is AWS is a kind of least permissions first model. And so at some point, the Chekhov CLI that will run as part of this CI/CD pipeline is going to need access to the API key. But by default, there is no access to that API key we stored with the SSM command. So this command here, this object in AWS is not accessible by this code pipeline, and neither should it be. And you see that's exactly what we get. We try and access the variable that we need, and we don't have permission to perform get parameters on that resource. So what we need to do is we need to go and edit the permissions in IAM to allow code build to access the API key we've stored as a secret. And so to do that, I'll just show you where this is. It's in 5.3 for those following along at home or later. What we have here is we go into IAM, we find our role here, and we just give it the permissions to access that secret. Because when we built that pipeline, the code build created a new role for that pipeline to run as for us, and it was named programmatically based on what we called the pipeline. So we can click here to get to the IAM dashboard. There we go. And then if we go into roles and look for that role, we will have that code build Bridgecrew tutorial service role. And then what we're going to do is we're just going to add a new inline policy to that role to basically allow us to access the service we need to access. So again, all here, add inline policy. Then we can find what we need. And so what we need is get parameters and get parameter. So choose a service, and we can just search based on this. Oh, so we need to choose the service of SSM.
Yeah. Systems manager.
Systems manager. That was the little thing that was stuck in my brain that I could not remember the name of earlier. Thank you so much, Rob. Appreciate it.
No problem.
This is why we've got the full force of AWS on the webinar. Perfect. So our secret stored in System Manager, which for the life of me, I could not remember what that name was for the SSM action we ran earlier. And then within Systems Manager, we need the get parameters, and you can see it all fills automatically here. So we need get parameter and get parameters from there. Now, obviously, we don't want our CI/CD system being able to access every single parameter being stored as a secret inside Systems Manager. So it's very important to limit your IAM policies to the specific resources you need. And to do that, we use the resources section, and we can have a specific resource. We click add ARN. And we can either build that by pasting in our region and our account and what the ARN is of the name is of the item. But there is a quicker way to get that out of the CLI. So if we look down here and we look past this CLI command, and what we're basically doing is asking to get the parameter we stored earlier. So if we just run this in our Cloud9 environment, you'll see that the ARN without the quotes is the bit we need from the bottom of that output. And instead of trying to build that ARN using the UI, we can just straight away go and paste that in there, and it'll fill that out for us. So once we've added that, we've now allowed get parameter and get parameters access to just that resource within Systems Manager. And that is all good for us. We'll give it a name. And I'm going to try and be consistent. I'm going to try and say, yeah, we'll call it allow code build access to Bridgecrew secret, because there's nothing like a bit of verbosity on a Wednesday evening. So we'll do that. We'll add that and we'll create that policy. Okay. So at this point, our code build pipeline will have access to the secret, which will allow the code build pipeline to do its job. And obviously you'd have to do that with other secrets if you wanted Systems Manager to also store secrets for, other API resources that maybe you're doing a deployment to, maybe give it IAM access to an EKS cluster to do the final deployment to Kubernetes or something like that. So, quite a useful process to understand if you're building code pipelines. So at this point, what we could do is, because I did a manual build before, we could just retry the build. And because we now have permission to access this, we'll see what happens. This will now go ahead and do exactly the same thing, but we should get a nicer output with less of a permissions error. Do we have any questions quickly while we're waiting for this build, or are we all good?
Yeah, there are a couple of questions. Let me address the first one. Boran asks if there are AWS credit codes that are gonna be provided. You should be using the Event Engine environment. We're taking care of that cost, so there are no AWS credits involved. And follow up, John had a question regarding not being able to retrieve the parameter. Just make sure you're in the correct region and that parameter exists. Yeah, that was it.
Cool. No worries. That sounds awesome. Thanks, Rob. So we're seeing much more useful output here now. You'll see what's happening is we're installing Chekhov. Like I said, Chekhov is alias to Bridgecrew, so you can pip install either. So we're effectively installing Chekhov here. And then we are setting a load of variables based on, which account this is coming from. And, the Git repo is on master, and this is the latest commit. And we'll use all that to save that into Bridgecrew in those kind of build logs, just so you know that this came from this pipeline with this commit and all that kind of good stuff. And what you'll then see in the CI/CD output is exactly what you'd expect to see. The whole point being we're automating running this Chekhov scan instead of you doing it locally. We want to do it on every build. And we can see that here, and you can see bad things like hard-coded secrets in Lambda environments because this is CFN goat and it's purposely vulnerable. So you'll see all the output here. And then just like we saw on the CLI, there's also a link to the saved version of that in Bridgecrew in the code review section. So because this is now running in CI, we know that this is coming from a new CI/CD pipeline. So instead of it being run 3 or 4 based on what we were doing locally, we know this is coming from a new source. So it's the first run that we've seen from this new source. And also, while we're waiting on that to load, we can see that the AWS code build integration has gone green. So we can see which account that's come from. We can see the name of the pipeline that has now tied in and called Bridgecrew with this information. And we can see that that's a successful integration with Bridgecrew of AWS code build, just like our AWS accounts go green when we're receiving data from them. So if we go back here, we can see now in the run, it's exactly what we saw from the Chekhov upload manually. It's exactly what we, the same output, the same issues that come from Chekhov, again, just in this much nicer to view solution, which obviously also allows you to historically go back through your code builds as well. Cool. So the next piece is, it's all well and good, but if I'm clicking that little run button every time I want to scan, I might as well be running the checkoff command manually. The way that AWS code build works is you use code pipeline to basically trigger on events. So what we can now do is we can basically create a code pipeline instance to automatically trigger that pipeline for us every time there is a change to that Git repo, every time there's a branch, every time there's a new commit on master, whatever you decide can be triggered based on code pipeline. And in 5.4, we cover setting that up. So we can call this scan CFN goat pipeline. And again, there's quite a lot of default settings here. Yep. And then again, this is GitHub integrated. So we're going to use GitHub version 1 just for the sake of some of the security policies in place in the event engine. The reason it says V2 on the instructions is if you are following along at home, or you kind of send a colleague to this to do the workshop themselves that's running on their own environment in their own AWS account, we do recommend the V2 integration. But for now, yeah, we go V1, and then just like we did with the code build, the code pipeline allows us to just quickly authenticate to GitHub. And this gives code pipeline the permissions needed to register a webhook, so GitHub can tell code pipeline as and when things are happening. Everything else is pretty similar. Once we have a connection, we connect to GitHub, as we've just seen, and then we select, once we're back from GitHub, here, we have the ability to select which repository we care about. Let's go and do that. So here we can go CFN go, slightly different instructions for V1 to V2. Oh, no worries if your code build is still in progress. You'll be able to go back and check the results of that, and you'll see that CFN Go output is very similar from what we were doing on the CLI. And it's going to kick off automatically when we do this anyway. So, okay, so we can select and you can see because we've authenticated with GitHub, it knows which repos we have. It also knows the branches on those repos. So let's say CFN Go and master, and let's go ahead. And then our build provider is code build. So we've chosen the repo that we want to trigger on changes. And then we also get to choose the code build pipeline, which gets run based on that trigger. So we'll pick Bridgecrew tutorial, single build. And then the deploy stage, like I said, is what happens after our build phase has finished. So in this pipeline, for example, we don't have a deploy stage. We're not actually going to deploy CFN Go because it's very, very vulnerable. But in a regular pipeline, if this all passed and there were no issues with checkoff or no issues with anything else in the pipeline, we then want to go to a deploy stage where we actually made those changes in production. But for now, we will skip that deploy stage. And we will create our pipeline. And then as you can see, very simply what code pipeline is doing, if we notice changes in this source, we will go ahead and we will run this build. And as soon as you create that pipeline, it's actually going to go ahead and trigger an initial build for you. So you will see back in code build, you'll see that we're now running a second build. And so just a quick thing to note about the way we configure the code build pipelines. If we look in report history, we actually output a kind of JUnit XML format report within code build itself. So, you know, just easy to at a glance kind of look at a build from within AWS rather than reading through the kind of output of the CLI as well. So, and that's something you can do on checkoff CLI as well. You can output in different formats, and that's what we're using here within the pipeline to achieve that. So what we've ended up with here is a scenario where if we make a change to our infrastructure as code repo, it's automatically going to get scanned with Checkov. And whether we are looking at it within code build itself for developers going, okay, what stopped my build progressing? You know, I've clearly got some security issues to fix, or whether we're looking at it from a wider view across multiple projects with the code builds project and filtering on those incidents as like the security advocate on that DevSecOps team, or even a wider security team kind of looking at that incidents dashboard in Bridgecrew. We can see that we've now automated doing security scanning on infrastructure as code. And then within the pipeline that's now running, you'll see, we can see the CLI output. I've kind of showed the JUnit XML. And, you know, we've done quite a lot in an hour and a half. We've kind of introduced infrastructure as code. We've introduced infrastructure as code security scanning. We've shown some vulnerable code. We've gone and built a CI/CD pipeline in a new AWS environment from scratch. So, you know, if you're still hanging out with us and still following along, I think a sip of whatever beverage you have in your hand and a heartfelt pat on the back is pretty good. So at this point, you know, we will see within the Bridgecrew dashboard that everything we've done has come along with us. We've now seen the CI/CD input come in here as well, instead of just our manual inputs as well. So, and you can see that there, that's the name of the CI/CD pipeline that we're coming from as well. So it helps you differentiate from just local scans and things like that. And again, all of that kind of adds to your total security posture in the dashboard. And all of that adds to the filterable items in your incidents list as well. So as you can see here, we'll now have more items to filter, such as the Bridgecrew tutorial, at that AWS account, and that's the CI pipeline name that we can filter on. So if we just look at that, that'll just give us the things from the pipeline. Cool. So the next section is just a quick detour while we're talking about CI/CD pipelines. Appreciate not everyone has the choice of where the pipeline is. As I said, most people will already have a pipeline that they're adding to. So I want to cover a couple of points on that. So first of all, when we were looking at the integrations and we were creating a AWS code build pipeline, if we actually go to add subscription, because you could add multiple of them, obviously, it doesn't just have to be one for any of these integrations. And when we actually look at this, you will see there's phases to any CI/CD pipeline. We have an install phase, which installs the Checkov or Bridgecrew CLI, interchangeable words. We have a build set phase, which actually runs the commands you'd expect, Checkov-D with the API key, give it some information for the repo based on the code pipeline and branch, and then output the test results XML. And then this is specific to making sure that XML appears in AWS Code Build as a report. But you can see there that those two sections in any existing code build pipeline would, as long as you have this parameter store key and you set these variables as part of that pipeline, those two, you could just drop those and rename those as phases in an existing pipeline. You know, follow the same instructions and just add it to your existing pipeline. Hey, Yaniv.
Hey, how's it going, Matt? I think we got a really nice question here on the chat. Maybe we wanted to talk about this. So the question is, can we raise a PR or a pull request, I guess, from Bridgecrew code review as a fix? And I have to say, I saw a few weeks ago, I don't know if it's recent or not, but I saw a nice blog by Peyton about keeping infrastructure secure with every commit that you do to your code. So in general, can we talk about maybe what are the best practices kind of when we do remediate to keep that, to close that loop of pushing code all the way from from our GitHub repositories and then fixing them as they go into production?
Sounds great. Yeah. What a great question. And it kind of ties that, I started the conversation talking about that entire life cycle. And yeah, where would we be without the solution, the remediation? And so module 6, and I'll come back to other forms of CI/CD. Module 6 is all about, okay, we know what the problems are now. We have automation blocking our CI/CD builds, not letting things go to production, maybe if we choose to do that within our code build environment, if there's problems, what are we going to do about it? So we've already kind of seen and jumped through kind of looking at the violations, filtering the violations within the Bridgecrew dashboard, which is kind of covered in 6.1. We've covered that quite extensively. But what if I want to do something with a fix? As we saw with the code reviews, Bridgecrew actually already knows how to fix a lot of these issues, which we kind of covered earlier in the webinar. We're already actually providing diffs in this output going, hey, like if you change this, this would fix the issue. Wait for that to load for a sec. It's taking so long, but I am keen to, let's have a look, one of these. Seems fine. I'm just going to refresh this page. I think I might be stuck in JavaScript hell at this point. Oh, there we go. Typically it loads just as I click exit. But yeah, you'll see within here, we're actually suggesting diffs. We're suggesting, hey, if you put this in this CloudFormation block or this Terraform block, you will solve this problem, like you will secure this resource. And so we already know we can solve these problems. And you will notice that on the incidents page for certain resources, we will offer let me find a couple of those resources in question. So let's find something with S3. There's this grayed out fix button. And the reason I can't press that at the moment actually comes back to what a CI/CD pipeline is. And a CI/CD pipeline is not something that realistically should be making changes to your code base. If I fix something as part of the CI/CD pipeline, well, how does that get persisted? Like if it's like Git is my source of truth, and if I'm not fixing it in Git with a commit, then I am kind of not really doing a good job of infrastructure as code. I don't have a commit that shows a change happened. I don't have something I can revert. So we shouldn't really be dynamically changing code as part of CI/CD. But instead, what we need to do is tie that issue we found in our CI/CD pipeline to the issue and then fix that directly back in our source control. And so we can do this through GitHub integration. So again, on the integrations tab, we have the ability to directly allow Bridgecrew to read and submit pull requests against our GitHub account. So in here, you'll see I've actually already attached my GitHub account, but go ahead on the instructions in 6.2, go ahead and click authorize and click authorize on GitHub Marketplace. Very much like authorizing with Git for the code build for our CI/CD pipeline, it will ask you to authorize Bridgecrew to access and be able to do all that stuff for your GitHub account. And then once you go back through from GitHub, it will ask you, you'll get a pop-up like this, and it will ask you which repos you want to scan by default. Now, that matters because you might not want to give Bridgecrew access to all of your repos. So you'll see here, for example, just for the demo, I've enabled CFNGoat and I've enabled TerraGoat. Any that you do tick will automatically be scanned at the source code level. So we'll also add incidents that we find in CFN or Terraform to the incidents page, even if you don't have a CI/CD pipeline set up. Now, it's important to have that CI/CD pipeline as well, because CI/CD is the only place you can actually block a change from getting to production. So just because the incidents will be automatically flagged and provided here, it's that whole security defense in depth. We really should be scanning the code while it's in Git. We should also be scanning the code as it goes through our CI/CD pipeline so we can block it. And we should also then be scanning what ends up in our runtime environment, because maybe someone came and made a manual change outside our CI/CD or outside Git. We need to detect drift on things like that. So once you've selected once you've attached your GitHub account and you've selected CFNGoat and clicked done, as I said, I've already integrated this, you will see a couple of things happen. So first of all, once we've scanned those repos, and again, you can differentiate, the whole point of the incidents page is it will show all the failed policies kind of together with the default filters with all the accounts selected. So let's just look at all of these accounts for now. If we look at ensure S3 bucket has a block policy enabled, you will see that I am getting violations on this policy from my local runs of Chekhov, from the CLI at the beginning of this webinar, from our CI/CD pipeline, and also now from our, show more. I do have quite a lot integrated with this account, but also down here from directly my metahertz/CFNGoat GitHub resource. Okay, so these ones down here are directly scanned from GitHub. And because this is coming from GitHub and I have the ability to raise a PR, whereas I can't really change a CI/CD run because it's ephemeral, when we have a suggestion like this, so for example, I've searched for S3, I found the ensure S3 bucket has block public policy enabled, if you're following along with this. I found my Git repo/CFNGoat, the data science bucket, it's suggesting this configuration change. I can tick this and I can click fix. And at this point, it's going to create a pull request to fix that resource directly in GitHub. Now, what's cool about that, and you'll see everything kind of coming together here, Yaniv, what's cool about that is once we've created that pull request, I'm directly back in, the developer's pipeline, what the developer's expecting to do to fix anything, be it a code bug, be it a security bug. So we see this pull request appear now. Oh, I was too quick for it. There we go. We see this pull request appear now directly from Bridgecrew saying Bridgecrew has a fix for this CloudFormation resource, okay? And we provide links to details and guidelines as to the why and what. We show which resource we're fixing. And as you'll see, the changes, the diff is exactly what we were suggesting in the diff we showed, which is these properties need adding to this bucket. So if we merge that pull request, you see, I've made a change. But that change isn't the end of the story. That change doesn't fix, was this issue in production? Had this issue already made it through a CI/CD pipeline before we added Chekhov or added security scanning to that pipeline? So if I go ahead and merge this into my CFNGoat repo, it's good to me. and I'll merge the pull request. There we go. Once I've merged this, and this is why we kind of show multiple resources for the same issue in the incidents page for someone kind of taking a full infrastructure view of their deployments. That issue will go away for the Git repo, because in Git, I've solved that. But it will still be showing because the last CI/CD run still had that issue. And potentially, if we've already deployed, you will see down here, we have buckets directly coming from AWS in our runtime environment that fall foul of this as well. So by making that PR, and I am actually just going to turn the runtime scanning off for now in the filtering, just because it's giving us quite a lot to look at. If we, again, go and have a look at this here, we can see that the bucket, hang on a sec, my browser is not letting me get down there for some reason. Let me just quickly check that PR again. Which PR did we fix? We fixed the data science bucket. So we can see in here that the data science bucket is now no longer listed for our issues against our Git repo, but it is still listed for our Bridgecrew tutorial because, you know, we last saw that being a violation inside our CI/CD pipeline. However, by making that change, what we'll have done is we'll have actually kicked off a code pipeline, because code pipeline will have noticed a change. And so you can see that code pipeline is already now running our code build against that new change that we've merged in. And what that's going to mean is that once Chekhov has uploaded those results, again, without that vulnerability, because we've now fixed it, we're going to slowly see that incident go away throughout our entire pipeline. We're going to see it, first of all, yep, it's been fixed in GitHub with this PR. It's no longer showing up in GitHub. Now we're absolutely sure it's gone through our CI/CD pipeline. We clear that violation from the CI/CD pipeline output. And then that allows us to know that not only have we made that change in Git, it's actually fixed because we have gone through and seen that change go from bad to good in the pipeline itself. And then the missing part of that to complete that circle brings us nicely onto, we've covered pull request fixes through GitHub integration. The last bit of that ties us nicely into that is AWS runtime scanning. And so as you'd imagine, this is completing that circle of going, okay, well, I want to see that that has also fixed. You know, the CI/CD pipeline has been successful. It's deployed that change to my AWS account, and I see that issue in my AWS account go away. Or I want to know if someone goes into my AWS account with the UI, for example, and manually makes a bucket public, that wouldn't be caught by my CI/CD because it's a change outside of CI/CD, but I still want to know if there's violations in my existing, you know, brownfield environment, for example. And so to do that, we can go into integrations. We can go into AWS read-only.
And if you don't mind, before going into runtime, we're just getting a follow-up question that I think is relevant also to the screen you showed before. And keep me honest if I'm giving the wrong answer here. The question is, what other source controls can we integrate with besides GitHub? I think it's Bitbucket, GitLab, and I don't know the rest, but help me out here.
Yeah, no problems. Thanks very much. Yeah, GitHub, GitHub Enterprise, GitLab, GitLab Self-Managed, Bitbucket, Bitbucket Server, Azure repos currently.
All right, thanks.
No worries. Cheers. So yeah, to kick off the AWS integration, you literally click Add Account and launch Stack. And as long as you're signed into AWS, which we are, through the magic of CloudFormation, we're actually going to deploy a really small, minimal permission necessary read-only connection to your AWS account, which allows us to compare your AWS environment, your runtime environment, against the policies that we've been looking at in Terraform and CloudFormation. So what we do is we go ahead and click Create Stack. And once this is created, we will see in here, we'll see this go green, and we'll see this new AWS account appear. And then all of the incidents we detect in the runtime environment will also appear in incidents. So, and just like we can fix certain things in GitHub with GitHub integration, we also have the ability to fix things in runtime. Now, obviously, if you're deploying through CI/CD and you fix something in runtime and you don't fix it in your original source control, you're going to put that change back next time you run CI/CD. But for customers that do have brownfield environments where not everything deployed in their AWS account comes from a CI/CD lifecycle, it's really useful to be able to use those quick fixes to go and remediate potentially a public bucket or something problematic. And here we see the new account coming up as the stack creation happens in here. See how that's looking. Create complete. Yeah, that's starting to look good. And so what we'll now see in, once that goes green, I might be being a bit over eager, but we will see. What we'll start to see is, yeah, there we go. We've got the extra AWS account name there, and we will start seeing Bridgecrew going ahead and scanning your runtime environment for issues it finds in the AWS account itself, which will take a couple of minutes, but that is that account. And as I said, in settings, you can actually alias these so that you don't just have a wall of AWS account numbers if you want to give them friendly names and things like that. The other cool thing, which I cannot possibly not show everyone, which we get with the GitHub integration, is automated pull request scanning. And so what better way than, instead of having to say, hey, you've got a problem in master, or hey, we've detected this problem once master's got to your CI/CD pipeline, what better way of helping developers in their day-to-day workflow than actually providing that virtual security assistant on a PR and going, actually, we recommend you don't install this PR, you don't merge this PR because we think there's some infrastructure as code vulnerabilities in it. Now, these are on by default in user management under code repository settings. You can see you can actually change some settings for this. You can exclude certain paths, and you can turn on and off pull request comments. So my pull request comments are on by default. So if someone went and created a pull request against my CFN goat repo, we would see pull request annotation. And just in the interest of time, I'm not going to do one of those because I don't have anywhere to fork my fork to in order to raise a pull request back against it. But I do have an example of that here. So we have a TerraGoat repo over here. And if we look at some of the open pull requests, we can see that someone's tried to update S3. And if we look at the changes, they have added a new S3 bucket. And you'll see even in the changes, we have annotated with the Bridgecrew bot, which you get by default with the GitHub integration and the GitLab integration for that fact. Hey, you actually need to not merge this because here are some severity high issues related to this piece of Terraform that's been added in this pull request. And we've also put that information directly into the conversation as well. So kind of providing that virtual security assistant to prevent new bad changes getting into your code. And then your GitHub integration, your CI/CD pipeline, your AWS runtime scanning, allowing you to remediate anything that's already in your IAC in master or main, and things that may be brownfield in your AWS account. Anyone have any more questions on that?
Yep.
Cool.
Hey, Matt. Just wanted to kind of dive in a little deeper on what sort of integrations you have with, notifying customers of high-risk items that arise. Is there like integrations that that can be implemented there?
Oh, so like notifications and things?
Yep.
Sure, yeah. We currently support down here in integrations at the bottom. So we support integrating kind of notifications of new items or changes with Slack and Jira and Splunk. But we're also looking at a kind of webhook API for people being able to kind of take and route alerts in a customized way. You know, the Slack integration actually already is technically a webhook if you were willing to, you know, use their format that we will send that in. But if you want, you know, if you think a custom webhook to do something would be useful to you, you know, please do reach out to us and let us know. We have a codified security Slack channel, which we cover discussions on Chekhov community contributions, kind of all things infrastructure as code security that we all hang out in. And so that's at slack.bridgecrew.io. So by all means, come and join us there and kind of tell us that kind of more generic webhook would be useful for you. We'd love to get some feedback on that. But yeah, as you can see by default, Slack and Jira and Splunk.
Excellent. Thank you.
Cool. And then, yeah, so just looking at the where we are at 6.4. So we've just integrated our AWS runtime scanning. And if we go back and take a look at that, and we just look at the new account we added, we can see we're already starting to get, let me refresh that. We're already starting to get some results in. Let's look at all. Let's just look at that new account. There we go. And, you know, we're starting to see some items with the AWS account that we're scanning. We're seeing some use of the default VPC, for example. So yeah, and this would allow you to find an alert on, for example, let's say everything else in my pipeline was secure, but someone, as I said earlier, had gone into the AWS console, had maybe meant to make a test bucket writable, but had made a bucket, you know, from one of your CI/CD pipelines writable. Nothing in your CI/CD pipeline kind of prevents that. So having this final, like, complete the circle with runtime scanning really enables full visibility from code to cloud of, you know, all of your infrastructure. And then, as I mentioned earlier, we can automate fixes in runtime as well. So we also do a lot of Iam scanning for you. So obviously, this is a brand new environment. There's not really much running in these event engine accounts, and the scan is, you know, only just kicked off with the integration. But as you will see from my other AWS account, which Blue Peter is going to be lost on a lot of people that didn't grow up in the UK, but that I made earlier, for those of you that get that reference. As I go and look at this other account in our incidents page, I already have kind of one of our more full, more interesting demo accounts connected. And you see we have things here like, you know, we have a bucket without versioning. Now, I could fix that. And the way I would fix that here would be to set up the AWS remediation stack in integration. So as you can see, it's going to let me click fix. It's already telling me, you know, which resource, which account it is. The AWS remediation stack is an addition to the AWS integration. So again, it's integrated in exactly the same way. You come through here, you acknowledge this, and you click create stack. The reason we've broken that up into two in integrations is we appreciate the sensitivity of something having access to your AWS account. So read only gives an absolute minimal set of permissions that we routinely test to make sure we are not using more permissions than we need to, just to see the metadata of your resources so that we can security scan the posture of those resources. The remediation stack allows us to actually go and make changes on your behalf. And so in order to live fix runtime environments like I was just doing, wherever the tab was, lost it, I think. But yeah, in order to do those live fixes, as you can see, now we have that remediation. I can actually go ahead and do that. Cool. And then just before we wrap up with a conclusion, and we've got, a good few minutes for any questions, so keep them coming in. And, like I said, these environments will not just disappear as soon as we disconnect. Join the Slack, ask any other questions, spend some time in the event engine environment to kind of go back through this at your own pace and maybe, play around and try some other things with the pipeline. One thing I did want to mention when we were talking about CI/CD pipelines, obviously you might already have, or you might join a team with an existing CI/CD pipeline in place. And as mentioned, we do support other CI/CD pipelines. So one I just wanted to really quickly cover that we have in the workshop is GitHub Actions. And so GitHub Actions integration, once again, through our integrations page, is pretty simple. We can go down here, we can find GitHub Actions, we can add a subscription. And what that's going to give you is, just like we did with code build, it's going to give you what you need to put into GitHub secrets so that GitHub, when it runs Chekhov as part of the pipeline, knows that API key to talk back to Bridgecrew, and then it gives you the step to connect the GitHub action job. If you are not already as part of Bridgecrew, or you want to tell someone else to try this out that is running GitHub Actions, from GitHub themselves, we actually have if we go into Actions, sorry, give me a sec, I'm just going to do this on my own fork. Let's take CFN goat, a teragoat. If we go into Actions, you can actually use the built-in GitHub action Chekhov. Don't know why I'm not finding it. There we go, from the GitHub Marketplace. And you can actually see another example there. But if you're already in the Bridgecrew console, the key, everything you need to do is already set up for you. So you can literally just copy and paste that into a new GitHub action configuration. Again, even without GitHub Actions, you'll still get the automated PR scanning. So it's just that extra defense in depth of making sure you're covering the whole pipeline. And then in conclusion, that is hopefully some kind of, in-depth, start to finish, kind of code to cloud, as we call it, intro to securing your infrastructure as code deployments. There's no reason they can't be in your pipeline. These tools allow you to test them, fail on them, and raise them to the people that are relevant, without needing manual steps, as just part of the same pipelines that are going to be building your code, building your containers, and doing your production deployment. And hopefully through looking at kind of how AWS and Code Pipeline and Bridgecrew work together, we've given you all some food for thought. And yeah, any questions, please do reach out to us on our Slack or tweet us, or just follow up with us. And yeah, happy to have those conversations. Thank you everyone for joining us today.